Hi, everyone. This is Miss McConnell.
And Mr. Huff.
And together we are going to go over what we expected you to do on midterm 2. One thing to note right off the get-go is that we are very much regretting at this point, after looking over all of your midterms, permitting a graphing calculator. Unfortunately, what ended up happening is because of the over-reliance on the graphing calculator, students demonstrated far less understanding than they could have. We'll cover a couple examples of what we're talking about as we discuss what we expected you to do and how we expected you to do this problem. On this midterm, remember we said that graphing calculators were permitted, but for all problems you still needed to show all work and justify reasoning clearly using words, numbers, symbols, diagrams, or a combination. Because you had your graphing calculator permitted, and because we took note of who had a graphing calculator, also it was quite obvious who had a graphing calculator based on the work, we graded these pretty harshly unless it was clear that you didn't have a graphing calculator because you had an additional tool.
Yeah, it should also be noted that the calculator was meant more so as a comfort and a way of checking yourself, not the sole means to solve any of these particular problems, which is how they were used.
Instead, what ended up happening was students would do all this work on the first page. Sometimes they wouldn't even do any work at all on the first page. Most people did, but then on the second page, their work would completely contradict their first, and they would put absolutely nothing on there that demonstrates, hey, this is a red flag to me because of this, but I have to keep going. So let's talk about how we expected you to engage in this task. First things first, you have a polynomial, q of x, which equals negative x to the fourth minus 4x cubed plus 3x squared plus 12x. There's a step automatically that Mr. Huff and I like to do, which is to immediately
factor out that x, right? You can't use the rational root test because we have a constant of 0, and all the factors of 0 are 0. So we only have one thing to test. And so we need to create a new form with a constant term to look at.
So my preference was to go ahead and factor out a negative x as well, which you could have done in 2 steps.
Or not even at all. You could have left it in.
You could have. There's lots of ways to engage in this problem. In fact, a lot of students, instead of factoring out the monomial term, they just went straight for factoring by grouping. One of the reasons we chose this polynomial was because it had an opportunity for grouping. Instead of the rational root test, which we thought would make it open and reasonable for you to engage in this with multiple ways. But we anticipated that you would use the rational root test. You want to talk about that, Mr. Huff?
Yeah, so the rational root test, right? We're no longer considering this negative x anymore. We're dividing this new version of the polynomial, the smaller version, the x cubed minus 4x squared plus 3x plus 12, because now we have a constant term, we have a leading coefficient, and we're going to list the factors of 12, which will be 1, 2, 3, 4, 6, 12, and those will all be over the factors of this leading coefficient, which would be 1, and it would be a plus minus. So you'll have a potential of 1, 2, 3, 4, 12 different things to check. Again, you had a calculator. This could have helped speed things up, but wasn't necessary. None of these values are too large that you can't just plug them in a reasonable amount of time. And so what you would have done from here is you would have tested all of these potential roots to come up with x equals negative 4.
Now, the way that you would do this time efficiently without a graphing calculator is you would check to see if ones were even reasonable to test. For example, I completely eliminated 1 as a possibility right off the bat because looking at the structure of this equation, 1 and -1 will never be able to reach this 12 just by looking at anything that's going to be multiplied and added by 1 and then added together. So you can completely skip some of these. When you substitute -4, you'll notice you get an output of 0. So of course that means you have an x-intercept there, which is your root. Now what you need to do is you need to identify that x equals -4 will correspond to a factor of x plus 4. But then you need to determine what that root is. So you need to do some form of division. You can use an area model or you can use long division. Some students decided to use synthetic division. Incorrectly often. And unfortunately, that means that you got no credit because synthetic division, when you make a mistake, shows you absolutely nothing. Nothing at all.
That's why we avoid using it, and that's why we avoided showing it to you.
And we cautioned against it as well. So now what we're going to do is I'm going to do long division to factor out the x plus 4. Now, what you'll notice here is that you will start off with an x squared because you're thinking x times x squared is going to get you that x cubed. And what's really interesting about this particular function is that you get x squared. Oh, oops, I need to make sure I actually factor out my negative here.
The 3x. 3x.
Thank you. So I need to double check. There we go. So what you'll notice here is that x plus 4 times x squared gets you x cubed plus 4x squared. That means my whole quantity is 0. And I like to put 0x squared here just to keep those all straight.
Yeah, keep everything consistent.
And then bring down that -3x. So you'll notice here that in order to get x times what equals -3x, that value has to be -3. And I need to line it up with my constant term because it's a constant. And so I get, let's see, that would be I'm subtracting -3x. And then I have -12. Yeah. There we go. And notice how I'm lining up the like terms. And so that actually gets me, when I have -3x and 3x, that'll get me 0. And then I'll be left with 12. But if I bring down that -12, then I'm already left with 0 here. So that means that that factor is x squared minus 3. And then here is where we saw the biggest mistake.
Crazy things happened.
Yes,
Okay.
This is the most common.
So there are 2 potential ways that you could solve this, that you could completely factor this. What we're thinking is you saw this negative and you automatically just thought there would be an imaginary number. Don't automatically think anything. You should still go through the motions and through the steps and see if it in fact will be the case. So you could have either taken this x squared minus 3 and set it equal to 0 and solved, and if we solve for x, we get x squared is equal to 3, and so x is then equal to plus or minus root 3.
Here's your check. If you have a second degree polynomial, you better have 2 roots. So if you are trying to remember when do I have a plus or minus here versus when it's just the positive, you better be checking to yourself that you have 2 corresponding roots if you have a second degree polynomial.
The other thing that you could have done was the quadratic formula, which would be, in this case, we have x squared plus 0x minus 3. So our a term is 1, the b term is 0, and our c is -3.
Which we're not going to do for you on this, are we?
I was going to.
Okay.
I had enough people mess it up.
Oh, sure.
So a lot of people didn't put 0 here. They just, I don't know what they thought was there.
That's the negative b part.
Yeah, negative b plus or minus the square root of b squared, 0 squared, minus 4 times a, which is 1, times c, which is negative 3. All of that divided by 2a. A is 1 again. And so I'm not going to write this. It's not needed to be there. It's already 0. So plus or minus 12 over 2. You can continue to deal with this. This would be plus or minus the square root of 4 times 3 over 2, which is equal to 2 root 3 over 2. Those 2's divide, and we get plus or minus root 3. So not the most efficient way, but it works.
And
a little bit more efficient, and it helps to double check that we in fact did everything correctly.
And we also, the students that chose the quadratic formula, they didn't make the error of forgetting the plus or minus. But again, they made other errors. They made algebraic errors, but they didn't make the error of forgetting a plus or minus. So that is one thing to note. However, that was unclear. I wanted to fix that. So you didn't forget that there were 2 roots here, but you may have made more algebraic mistakes here. Whereas in the other one, it was more often that they forgot a root altogether. But again, you have a 4th degree polynomial, which means what, Mr. Huff?
The fundamental theorem of algebra states that we will have 4 roots, real and complex.
So when you go to list the key features, you need to make sure that you list all of them. And the most common error I saw here was that people were listing their factors. Factors are not roots.
That's a root.
This is a root. This is a root. This is a factor. And then you had root 3 and negative root 3. You could have written it as positive and negative all in one if you wanted to.
And again, take note that the instructions say to use exact values. Root 3 is the exact value. A lot of people were putting 0.17, blah, 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 whatever the decimals were that were trailing after on your calculator. But that decimal goes forever. And so that means anytime you round it, you are now at an approximation of root 3. And if you took that value and used it into your polynomial, you would not get 0.
Yes, exactly. So this is exact and it's more precise. Then when you're graphing, looks like my graph ended up printing on the next page on this one. But when you're graphing, we were extremely clear that you needed to have a set of clear scaled axes and clearly labeled key features. So this is how you do it without a graphing calculator. You know you have a negative leading coefficient, and so you know that that means that your ends are going to be pointing down. You also know your roots. The only time it's appropriate to approximate your roots are when you are putting it on your graph. So I am going to leave here. I'm going to start by plotting my roots. So I have -4, I have 0, and then my root 3 is approximately 1.7. That's appropriate to approximate here because you're going to be plotting it on the axis. And so then of course you have the -1.7 as well. Start by using your ends. Now all of our roots have multiplicity. That tells us they're all going to cross, and then you can just kind of go ahead and estimate where your mins and maxes are going to be because you don't have your graphing calculator. Like we said before, your graphing calculator was supposed to be just an additional check for comfort, and the only appropriate use really would have been to get more precise mins and maxes and intervals of increase and decrease. Notice how I didn't have to use anything with the calculator until this point. And so this is probably the most disappointing part for Mr. Huff and I, because students would have imaginary roots, but then their graphs would look like this. If you had imaginary roots, your graph better have looked more like this, where it was only crossing the x-axis once. Now, we're going to go ahead and pick up this video in a part 2 because we're going to get cut off in a moment. Plus, this video is getting a little bit long, and we'll finish up what we expected.
Mm-hmm.